Today we're going to look at section 3.8, which is inverses and radical functions. Remember from back when we looked at inverses previously that when we went through and did composite functions, or putting one of your functions in for x into the other function, if it would simplify to x, it means that they are functions. Remember that you don't have to do both, and the domains and ranges are switched. The domain for one is the range of the other, and the range of one is the domain of the other as we go through. So what we're going to do first is we're going to go through and show and see if two functions are inverses of each other or are true inverses of each other. So first we're going to look at these two functions. Okay, f of x equals 1 over x plus 1, and the inverse of x is 1 over x minus 1. We want to go through and see if these two functions are inverses. Now, keeping in mind, since we're looking at rational functions, there are certain things that our x cannot be. Remember, we cannot have a 0 in the denominator. So we are assuming that x cannot be equal to 0, nor can x be equal to negative 1, which would make a 0 in our denominator. Basically, it does not matter which one we start with, but I'm going to start with this one. So my f of x function, I'm going to go through and plug in my f of x function in for x. So I'm going to leave this function alone. My f of x function is 1 over x, oops, if I write it correctly. There you go. My f of x function is 1 over x plus 1. And what we want to go through and do is we're going to plug in this right here. We're going to plug that in for x in our f of x function. So our f inverse function is 1 over, now in place of my x, I'm going to go through and plug in a 1 over x plus 1 in for x. Okay, and I still got this minus 1 behind my function. Well, remember with this part of our function right here, we keep our first function the same, change that division and multiplication, and we flip our other function. Okay, and we still have this whole minus 1 into here. Okay, so in this one, multiplying by 1 doesn't do anything, neither does dividing by 1, so it becomes x plus 1 minus 1. Those two would simplify out, so that one is equal to x. Now keep in mind that you don't necessarily have to go through and do both, as long as you can show that if you insert or substitute in one function in for x for the other and it simplifies to x, it means that they are inverses. We're going to go through and look at both anyway. So now we're going to go through and look at f of f prime of x, or inverse. So that means my f prime is 1 over x minus 1, means in my f function I'm going to plug in this in for x. So my f function was 1 over, and in place of my x I'm going to do 1 over x minus 1, and then it still has a plus 1. Well, in this case those two would easily cancel out, and I end up with this complex fraction again. So for the top, I'm going to leave that one alone, change my division and multiplication, and we flip our last fraction, which again is going to come out to x. So that means that these two functions are true inverses of each other. Alright, and there's another example in your printed out notes that I emailed you already as well. Alright, so let's say I'm given this function and I want to go through and find my inverse. Again, your steps to find your inverse is you want to switch your x and your y. So this function is y equals 5x squared plus 1. But I want to switch my x and my y, so it's going to become x equals 5y squared plus 1. Well, I'm going to have to go through and I want to solve for y, so I'm going to minus 1 to both sides. So I get x minus 1 equals 5y squared. Then I got to go through and divide by 5 to both sides. So I get y squared is equal to x minus 1 over 5. Well, now I have to get rid of the square. And to get rid of the square, I have to square root both sides. So I get y equals, and when I take the square root, I got to remember the plus or minus, square root of x minus 1 over 5. Okay. Now, keep in mind that when you're going through and finding your inverse for these different functions, keep in mind that it has to be a one-to-one function. So a lot of times we're going to have to restrict our domain in order to be able to find an actual inverse. And that's true for this one as well. It is a quadratic. A quadratic means that it is not one-to-one, or that horizontal line test. So technically we would have had to restrict our domain as well as restrict it as we're finding our inverse to it. But this was just kind of an overview to remember how to find your inverse. You go through and you switch your x and your y, and then you get the n and y equals. Alright, so let's take a look at this function. And this one we're going to go through and restrict our domain and let that help us be able to find our inverse to it. So first off, if I was to go through and look at the graph of this one would have gone to the right 4, and it would have looked something like this. However, the problem is that if I were to go through and do the horizontal line test, going across here, oops, it hits more than once. Okay, so this is not a one-to-one function. So what we have to do is we have to go through and restrict our domain. So in this one, I'm going to get rid of most of these lines real quick. So we want to go through and restrict our domain, okay, to make it a one-to-one. So in this case, I'm just going to restrict this one to all x's greater than or equal to 4. Okay. Now my function is a one-to-one. So when I start going through and finding my inverse, I've now restricted my domain to x greater than or equal to 4. Well, so again, we want to go through to find our inverse. We've got to switch the x and the y. So in place of f of x, I'm going to put an x. In place of this x over here, I'm going to have a y. Y minus 4 squared. Again, I have to get this thing in y equals, so I've got to get rid of the square first. So I can take the square root to both sides, so I get plus or minus the square root of x. I no longer have the square over here anymore, so it's just y minus 4. And I need to add 4 to both sides to get it in y equals. Now, because this one has a plus or minus, I'm going to put the 4 in front of it. So plus or minus the square root of x equals my y value. Now, here's kind of where the problem lies. With this one, if I were to go through and graph this thing, so we get 1, 2, 3, 4. Now, technically, here's my positive, and there's my negative. Okay? So, again, as you guys are going through and determining, whether you're using the 4 plus square root of x or you're using the 4 minus square root of x. In this case, that kind of leads us back to this original one right here. Remember, our domains and ranges switched. Our range for this one, okay, remember our range for this one becomes our domain for our other. So our domain for this function in this case was all x is greater than or equal to 4. So that means that's going to be my range. Okay, the domain for this one is going to be the range of this one. Well, my range to be greater than or equal to 4 means I'm going to be dealing with this top one right here, because that's all my ones greater than or equal to 4. So in reality, in this case, that one right there, just the plus version, so my f negative 1 of x equal to 4 plus my square root of x is my inverse of this one. Remember, inverse functions, 1, 2, 3, 4, I'm just graphing that one on this one right here, should be reflections across the y equals x line. So I need a different color in here. The y equals x line, and boom, boom, I can see it right there too. It is a reflection across. So there's a couple different ways of seeing this. Some of you guys may be a lot more visual, so when you restrict your domain to make it a one-to-one, you can visually see of the two possibilities, which one actually is your inverse function. Others of you, again, since our domain of our function, of our original f of x, is all x is greater than or equal to 4, that means that's what my range is going to be for my inverse. So that meant to me that I needed to use that plus 1. So let's look at another example. Let's say f of x is equal to x squared plus 1. And this one I'm going to restrict my domain, because some of your problems are going to already restrict it for you, to all x is greater than or equal to 0. Alright, so if I look at this graph, it would be a quadratic that would have gone up 1, and it would have looked something like that. However, we are going through and restricting our domain to just be all x is greater than 0. Okay? Well, what that means is when I do go through and find my inverse, that my range is also going to be all y values greater than or equal to 0. So again, if I want to find my inverse, I got to switch the x and the y. So First thing I would have done is minus 1 to both sides. So x minus 1 is equal to y squared. And then again, I take the square root to both sides, which is going to make that a plus or minus. The square root of x minus 1 equals y. Well, again, when I'm going through and actually listing out what my inverse function is, it's not going to be both the positive and the negative. Okay? If I were to look at a graph of those two, this one would have ended up being, let's see, I'm going to the right one, there's the positive one, and then there's the negative one. Well, again, that's where this kind of comes into play. The domain of my original function becomes the range of my inverse. So my range has, or y values have to be greater than or equal to 0, which means it's only going to include this top one, because that is the only one where my x's are greater than or equal to 0. So that means that is my inverse. It just means it's going to be the positive in this case. That's that one right there. So there is my inverse function. We also need to be able to find the inverse of a rational function. So again, when you guys are going through and finding inverses, especially with these, we do have a restriction. That's my cat, by the way, shaking his head. So when you go through here, first thing you want to do is switch your x and your y. So my x would be over here. Each of these x values are going to become y values. So first thing that you want to go through and do is we got to get this thing in y equals. So what I find to be the easiest thing to do is to take this x and put it over 1 and then just cross multiply. So if I multiply these two together first, I get xy, and then x times negative 2 is negative 2x, and then I cross multiply these two. So that becomes y plus 3. Well, now I have to get this thing basically into y equals. So for one, I'm going to have to get the y's on the same side. So I'm going to move this one over. And I'm going to have to get rid of this term right here, this negative 2x. So I'm going to also add 2x to both sides. So I'm doing both of those at the same time. So the 2x's cancel, these y's cancel, and I get x, y minus y is equal to 2x plus 3. And now that those both terms on the left have a y, I can pull out the greatest common factor of y. And now I can go through and I can divide this x minus 1 to both sides. So, essentially, my inverse function for this one is going to be 2x plus 3 divided by x minus 1. Okay. So again, with these you want to go through and switch your x's and your y's. And then I always go through and cross multiply. I think that is the easiest method to do. And then to get in a y equals, you're going to have to get all your y's on one side, pull out the greatest common factor, and then divide it out. Alright, so as you go through and start getting ready to work on your homework for these, the nice thing is number 6 and number 12 are also going to go through and give you the domain to restrict your domain in. Just kind of keep in mind that that's going to be the range of your inverse. You're not going to be using both the plus and minus. You're just going to be using one of them. And then 14 and 18, you're going through and actually finding your inverse function to it. 24, same kind of idea. And then 26, you're going through. So I'm not sure if I'll be able to get it in Moodle by this weekend because my laptop doesn't always let me. But in section 3.8, you're going to be doing number 6, number 12, number 14, number 18, 24, and 26. So your substitute has a key to all of this homework as well. So use that as needed, not just to go through and copy, but if you want to go through and check and make sure that your work's right. I would spend Monday going through these, and then I would be back on Tuesday morning if you have any questions. Keep in mind that we only have one more section after that. We have 3.9, and then we'll start reviewing on Wednesday, and our test is on Thursday.